Hello, in today's video we're going to be talking about the mole, but we're going to be talking about it in relation to formulas. So last week we learned how to name ionic bonds, we learned how to name covalent bonds, how to name polyatomic ions, acids, bases, hydrates, all these different types of nomenclature that we're going to be using in general chemistry. And through that naming, we're able to figure out what the formulas are for a given compound or molecule. Now we're going to be able to show, and I'm going to demonstrate to you, what's so special about formulas and what they can tell us about everything that's within that formula, all the atoms and elements that are present within that formula. So let's take a simple example. C6H12O6. So this is glucose. This is a sugar. This is something that you eat and your body gets energy out of it. So you eat this every day. So if I were to ask you, in one molecule of glucose, how many atoms of carbon are there? You can easily go down to their subscripts and say, well, for every one molecule, there are going to be 6 carbons. It's the same type of process as if I said, how many hydrogens are present in a water molecule? We know water is H2O, so there have to be 2 hydrogens for every 1 oxygen. So we're going to set that equal. That's going to be our standard, our starting point for this calculation. We know for every 1 molecule of glucose, C6H12O6, that's going to equal 6 atoms of carbon. That's just our starting point. That's what we're going to start from. Now I'm going to perform 2 different calculations. I'm going to perform one on the atoms of carbon. I'm going to perform one on the molecules of glucose and see if I can't relate the mole-to-mole ratio. So we found in the last video how to go from molecules or atoms to moles. We know that we're going to have to use that Avogadro's number, and we're going to, in this case, divide by it. So I want to start with the atoms. I'm going to do a simple dimensional analysis where I divide by the 6.022 times 10 to the 23rd atoms carbon for 1 mole of carbon. So this is something we know how to do already. Here the atoms are going to cancel, and instead of actually calculating this, I'm just going to keep them in ratio notation because I want to show you where everything is going to cancel. So here I'm going to end up getting 6 moles of carbon. 6 times 1 is 6, divided by 6.022 times 10 to the 23rd. The atoms of carbon canceled, so now we're just left with moles of carbon, and in the denominator, just a number. Now let's take this molecule and let's perform the same type of a calculation. We know for every 6.022 times 10 to the 23rd molecules of C6H12O6, sorry, I got so sloppy and squished, but this is 6.022 times 10 to the 23rd molecules of glucose of this for every 1 mole of C6H12O6. Here, the molecules of glucose are going to cancel, and what we're going to end up getting is for every 1 mole of C6H12O6, there are 6.022 1 mole of glucose per 6.022 times 10 to the 23rd. And in this case, we knew that the molecules canceled, so we have this relationship. This was our starting point. 1 molecule of glucose equals 6 atoms of carbon, so this has to hold true based on simple mathematics. Now what we can see is we can multiply both sides by the 6.022, cancel both of those out. I multiply this 6.022 by both sides, and I end up getting 1 mole of C6H12O6 is equal to 6 moles of carbon. Well, we can now, for any formula, know that for every 1 mole of their compound, there are however many subscripts of moles of each of those elements. So for every 1 mole of glucose, there are 6 moles of carbon, 12 moles of hydrogen, or 6 moles of oxygen. That is the power behind the formulas. With this information, we're going to be able to convert from moles of glucose to moles of each of those atoms. So if I had 3 moles of glucose, I can figure out how many moles of carbon there are present, how many moles of hydrogen are. And then from there, once we know the moles of each of these, we know how to go from moles to grams. because we use the periodic table and we're able to convert between moles to grams. So as a chemist, we like to stick with the moles because we can do a lot of conversions between them. So we're going to be working a lot of problems tomorrow based on the moles. This is a very fundamental topic in the world of general chemistry. But that's all I wanted to say in this video. So with that, I want to say have a great night, and I'll see you all in class tomorrow.